How many people do some sort of active probing for performance or topology on top of their network? So that's another kind of data source. One thing I'll talk about briefly is fusing data, which is to say just one silo is typically not sufficient to answer. Network performance analytics. How many people try to do something to look at performance by peer? Help, it's Windows. Hold on. F5. Boom. Oh, F5, okay. So, happy to be up here again. The purpose of this presentation is to be a little bit more of a survey of what we've seen people be able to do for their operations and business using data coming from the networks. We've seen just a lot of people, both carriers, service providers, cloud companies, and enterprise and content companies really trying to operate things from a data-first perspective, double-click on everything down to whatever level of detail they need. So that's the high level. I'm going to talk a little bit about what it means to be using data to drive operations, places that you can get the data that you need to do the crunching, a little bit about the older generation of tools and what the tools are that are out there, even on the do-it-yourself perspective for people that are building their own. Fusion, because in the sort of the old world, you would rely on the router to take maybe flow data plus BGP and fuse it together, but there's a lot of extra benefit that you can get by actually using modern techniques to combine this data together. And then I'll talk a little bit about some of the use cases that we're familiar with in terms of peering and planning, but also in terms of, I'll get down to the dreaded revenue enhancement down at the bottom, which is how people use this data even to try to find customers or protect the business that they have. So what it's about at a high level is using the data that you have available from your infrastructure components to try to run the business better. And to try to run the operations better. And it's really trying to be very specific and not just let's put all the data in a data lake and say we're big data, but let's solve specific problems. And DevOps has come a fair way. I'd say there's still a tremendous amount of suck in all the time series databases. Raise your hand if you love your time series database. Anybody? Okay, we have one. But there's suck all over the place on the analytics side. But still, Graphite. By the way, how many people here use Graphite as part of their network? So but with Graphite and modern tools, people have access to a lot of data, on the systems and side that we lack in many cases on the NetOps side. So there's a lot of work to be done. So what's interesting data? How many people here do something with NetFlow or SFlow or IPFix data? And BGP, at least you get to cheat and say, yeah, the router puts AS numbers on there, but you can even get other data from BGP. Has anyone played with the streaming telemetry? Either the Juniper protobuf or the Cisco, so QDepth that you can get out from the infrastructure. Event logs, we heard a little bit about that. Tagging and really slicing, putting business context into it. Server metrics we talked about. How many people do some sort of active probing for performance or topology on top of their network? So that's another kind of data source. How many people record topology, like LLDP or use something like so that's another kind of thing. Another really interesting thing is where are the tunnels going? What is that IP address or containers, and how does this all map together? That's another interesting thing that we're seeing. And how many people use DNS queries and tie that to traffic? That's another thing that we've seen. And then threat intelligence. A lot of carriers have backbone analytics needs, but also sell security services and also want to be good citizens. I assume everyone's heard about the OVH, more than 1 terabit attacks, the Krebs on security attacks, the cameras, non-BCP38 attack traffic. I think I don't actually read Nanog except when it shows up in my mailbox by accident. But yeah, lots of discussions about what's responsible for carriers. So imagine if we could get maybe even beyond those things that I think a lot of people have experience with, queue depth from streaming telemetry, or we use nprobe a lot. Nprobe can turn packets into flow, but now you get client latency, server latency, application latency, retransmits, out-of-order packets. You can do that on a sensor. Cisco AVC on some ASRs can send this. So the thinking about traffic data that goes beyond just where'd the traffic go, but how is it actually functioning for the users is an interesting thing. And nprobe, you can just go by and deploy like that. It'll send it as IPFix, so your tools can probably still take that data. A lot of interesting places if you look around. I've worked with some carriers who have their customers send them copy of their Nginx logs, because Nginx logs can look into the TCP info struct, and then you can aggregate that by AS and see performance problems across peers. So a lot of interesting places that you can get data, and again, I would encourage you to think about more than just standard flow as source. So what are the requirements? One of the big things that we've seen in a lot of the older generation tools is a lot of aggregation. So you take the data in and you do some aggregation, because it's really hard to store this data at volume. So a lot of people use big data architectures. I would say another thing that people do is streaming architectures like PipelineDB and Druid and things like that, where you can't keep the data historically, but you're operating over all of it and can very flexibly do kinds of queries. One thing I'll talk about briefly is fusing data, which is to say just one silo is typically not sufficient to answer a lot of the questions that people want to go to. A lot of the people that we've talked to really want to be able to store the data for a long time and to be able to access it, not crunching it for days, to be able to go and do it, and to be able to detect anomalies as well as do analytics and peering and planning. So that's what I think a lot of people that are trying to work in data-driven operations are looking at. I will go through some of this quickly because there's only a half hour, but anomaly detection, I think on top of the data platform is pretty interesting. How many people do any sort of alerting about traffic patterns on top of the data that they have? So, and how many people do DDoS detection specifically as a subset of that? So, and how many people use the same system for that? I was looking, okay, as for analytics, okay. So, so there's some people already doing that, which is pretty powerful. So I think probably PM account, I left enough, dump enough sent off here, excuse me, but there's a lot of open source things. PM account even winds up being a front end to people doing their own big data, because it can do the processing, it can turn it into Kafka, NTOP and nprobe can do the same thing. There's some even older open source. I don't know if I'll get anyone to raise their hands. How many people are still using MRTG? Anybody? Cacti? Okay, so there might be some people still using CFlowD. CFlowD, anyone using CFlowD somewhere? So per the conversation earlier that Frank was talking about, some of these older tools don't support IPv6, and so probably shouldn't have them on here. This commercial software, we see a lot of people building their own. I'd say number one, how many people have tried putting flow in Elasticsearch? So that's one that we see, and then the problem becomes fusion. How do you actually fuse all this data together and get it in there and query by prefix and take BGP paths and stuff like that? And how many people use any sort of columnar store database from Cassandra to Drill, Impala, Redshift? I was at a government conference in the US where they said, oh, it's awesome, we can use Redshift for NetFlow, it'll only cost $3 million a month. That's super cheap. So when you have the government, when you have the taxpayer's AWS credit card, I guess things look practical. So, and then there are some vendors that have come into the space. AppNeta up here is more on the application side, but they do even more rich sort of application decomposition, a little bit more towards the content provider. So a lot of the big data tools can support high volumes of data. Some of them are relatively efficient, but the fusion and the network savviness is missing. So most people, again, that try to do their own big data usually have some level of complexity in building the network savvy queries, and also another level in terms of data fusion. So just taking the flow or just the BGP data, like having a pile of MRT updates, and over here a pile of flow, and maybe even flow with Origin AS or next hop AS still doesn't tell you how the data worked in the middle. So combining all this data and having a tool that knows what it means to have hops and prefixes and things like that is important. And I think thinking about this, if you're building your own tool, lets you design in some of the kind of data inputs that you'd need. And by the way, how many people are sending network telemetry or flow over Kafka? Internal system. We see that a lot in the enterprise, a lot in the web companies specifically. Now it offends me deeply in my 8-bit soul that people turn beautiful binary data into JSON and then send it over stuff, but people like that because then they can debug it with ASCII like your SMTP. And again, I would just say, think even about things like threat intelligence, who's participating in a botnet, the emerging threats things, because those actually become operational problems, and I think we've only begun to see what attacks can be on the internet when people get really serious. So I'll skip over this a little bit, but we'll make the slides available. We've seen a lot of people that have architectures like this where you're taking this data in, you're building essentially routing tables. We actually use XBGP. We've used a few different ones, but a lot of the BGP daemons that are developed now are pretty good at that, so you can take flow and take BGP attributes. So to put it all together, what we've seen people try to do is get from aggregations to being able to keep it all and run fast queries on top. The challenge is it can take a lot of hardware, but then again, hardware is a lot cheaper than it used to be. And if you can do it fast, you can actually get real-time for non-financial trading definitions of real-time. I mean, I think most people in this room are happy if they can get data in under a minute from their infrastructure, that'd be pretty good. The challenges are fusion and how do you find the tools that understand savviness? For example, I think Elasticsearch just added some prefix level aggregation. But if you do all this, I think there's actually a lot of interesting questions that you can now answer that make your request to buy a pile of servers or a service or however you're solving the problem be much more well received. And some of them even have to do with revenue. Some of them have to do with availability. Some of them have to do with efficiency. And I'll talk about those very briefly. So I think everyone's familiar with traffic debugging, inspection, where's the traffic going. How many people here do any sort of abuse detection on their peers of, are people sending me traffic to routes that are not my peering routes? So that's something that we've seen people do that can be pretty reasonable to do. Not just, not are people sending me from a different MAC address, but I'm sending them 70,000 routes, but I'm getting, essentially transit back. Where's the traffic going to and coming from? A lot of those kinds of questions. So that's pretty standard stuff. A lot of people do knock views for the bosses. And then the key is getting tools that you guys can use for getting into levels of detail. So we're all familiar with the top talkers. And again, I would challenge you to say it's possible to not only think about just statically looking at it, but to get alerted to build systems, again, NetFlow to Kafka to even some of the streaming systems. And if you're building your own, I would strongly encourage you to look at Pipeline DB and then just store that and say, are there new top talkers on an interface or something like that? Something to drive, whether it's peering or even potentially transit or just attack, right? Or do I have new kinds of people sending me traffic in different places? And with DDoS, a lot of people really want to see where's it coming from, where's it going to, and by putting together BGP data, you can actually, this graph doesn't actually show it, but you can see, you can aggregate flow by middle hop. This kind of diagram is called a Sankey diagram. It's used in a lot of different NetFlow tools and network analytics tools. It's a lot of good code available for processing that. It's just D3. And the data, if you make a SQL query or something like that from a big data tool, it's basically just grouping by A, B, C, D, E, and it's just then laying out the data like that, and it presents very well to see where traffic's coming to and going from. It's very good for identifying people that you should buy transit from or peer with, or even take as customers that are a couple hops out as well to lay data out like that. So the network planning again, pretty briefly, How many people use NetFlow to identify new potential peers? Okay. How many use NetFlow to identify customers? Anyone willing to raise their hand? Okay, someone's willing to raise their hand. How many, okay, I'll ask that question at the end. Transit relationships, who should I be buying connectivity to? Again, where your traffic, your customers are sending traffic to changes over time. So this is an example of the Sankey diagram view, but understanding what the intermediate AS hops are. The value of taking the BGP data from an exit BGP or something like that, unifying it with flow, being able to query it out of your data system and lay it out like that. Now, of course, this is the outbound side. On the inbound side, you're making more guesses because you don't actually know where it came from. But you can still make some educated guesses. Okay. So network performance analytics. How many people try to do something to look at performance by peer? And actually, let me just ask, how many folks here run primarily content provider? So I would say that's more of a content provider type thing. So the big question, and how many people have ever heard, is the network the problem? Is it the network? The network's down. The network has a problem. And of course, the standard service provider answer is there's no known problem on the network at this time. And then if there was a problem, the next day you get a call saying that problem that wasn't there is fixed now. So you can go deal with that. So when I was at, well, it used to be called AboveNet, but when Blake and I were there, we had a large content provider customer, Danny's Hard Drive actually, who said their signups were down. And we actually exchanged data so that we got by AS the e-commerce signups from them. And it was a very crude way of being able to figure out whether there might be a performance problem by AS. So when Akamai then turned up and said, we know your shit is bad and we have the data, I said, oh, I need to go work for you guys because that's really cool. But using nprobe data, which again is something you guys can run on taps on traffic or by partnering with customers and aggregating it by prefix, AS, whatever, you can actually get retransmits and client and server latency, and I think that's very powerful. It's a little bit more of interest on the content provider side, but I think it's at least useful to know what the user experience of the traffic going across your network is. And bricks and pinging things and thousand eyes, it's all synthetic. And I'm a big believer if you can actually instrument the actual traffic and aggregate that way, you can get really good data. Because again, maybe you're peering with someone there, but their port is overloaded. You're not going to know unless you actually have some level of instrumentation of that. So security and breach detection. How many people try to monitor peers for whether they're sources of BCP38 violation? I know it's a messy, messy internet out there. How about customers? You have customers that are multi-homed and say, oh, no, you can't RPF us, but doing monitoring. So we've seen that. A very simple heuristic for that is how many /8s am I seeing traffic from? How many, not class A's, but that metric is a pretty good way to track down, especially when there's attacks, what's going on. And having a big data platform where all the data comes in can be pretty useful from a security perspective as well. And by the way, how many people are carriers who sell security services to their customers? I know there are at least a couple. Think of this as lead generation. So you can actually go talk to the customers and say, your stuff is owned. You're sending us stuff from not your IPs. Maybe you should buy some of our fine services. So now we'll talk about, on that path, revenue enhancement. So one of the big use cases for the business use cases for funding the backbone ops to actually understand traffic is ring, ring, hey, sales wants to know whether this customer, whether we can charge them 40 cents per megabit, whether we'll make money. Will we? And then how do you figure that out? So understanding the packet mile, which you can do from communities and make at least some geographic guesses, is a really interesting use of traffic-based processing. Again, traffic plus BGP, you're going to need to do some fusion because the router's not putting that in IP fix for you. or if you tried to, the RPDs of the world on the Junipers would crawl up and die probably, worse than they already do. So that's an interesting one. We've seen definitely people that use Sankey type diagrams and say, who am I peering with? Okay, well, who's behind them? People already use the Renesys, now Dyn, the BGP tool. So this is a traffic-based alternative. And to be able to figure out, okay, let me get those as customers. So a lot of interesting things. There's saving money, there's making money, and just generally running the network well. So I don't know how I actually finished that in less than a half hour. That was designed to be a very high-level overview just to get you thinking. A lot of different places you can get traffic, a lot of extra value that when you put it together. NetFlow or flow doesn't mean just NetFlow from routers. There's other interesting things that you can get, like performance data. And then what are the considerations as you try to solve that problem? So there's a lot of data coming out, but it can be very valuable. Big data approaches have been successful at being able to at least store and be able to do things with it. And you can do this on your own with staff, and there's a bunch of people trying to innovate in the space. And we've even seen people enable community views and data sharing, but obviously that's a very privacy-sensitive thing, so you have to be very careful what you do there. Like that. So I think we have some time for questions. What year will we have the magic network operational system? No, never mind. Sorry, Blake. Yeah.
Have you had any carriers or like broadband operators using this for quality of experience analysis, specifically like with their QoS configs and that sort of thing?
So let me answer that two ways, because this is not a Kentik pitch. This was a generic network traffic analytics. We've seen people who have successfully built that on their own. Yes, taking active measurement and passive measurement both, and router config, and actually generated almost all the way to configs to suggest, but always with a human in the middle. And then, the customers I've been working, the carriers that I've been working with in the cable companies most recently, for both VoIP and video, yeah. I should have put that on there, the actual router config is another interesting thing to extract data from. But the way a lot of flow tools take that is tagging, which I put on the list but didn't really get into, which is you program the flow system or the big data system to know based on the IP addresses of the interfaces what should be, and then use that to compare what should be to what was. So, no more questions? Happy NetFlow hacking.